All right, number 3. A light bulb marked 75 watt at 120 volts is screwed into a socket at one end of a long extension cord in which each of the two conductors has a resistance of 0.8. Hey, each of the two conductors, what are they talking about there? What?
They're in parallel.
No, they're in series. But when it says each of the two conductors would be the wires feeding the light bulb, right? Like inside an extension cord, there's two wires. There's the positive and the negative. So to diagram this, here's what they're telling us. Well, first let's just start with this first sentence. A light bulb marked 75 watt at 120 volts. So what that's saying is this. If we take that light bulb right here, hook it up to 120 volts, so this is the light bulb right there. The power of this light bulb is going to be 75 watts if there's 120 volts across it, which would be like this. So here's our battery. So positive plate is 120, negative plate is 0, right? When you're talking about voltage, it's always the change between 2 points. So the easiest way to do that is 0 and 120. So how many volts would we have right there? 120. How many volts would we have right here? 120. And then over here would be 0 and 0. So in this little diagram that I set up here, how many volts, what's the delta V across this light bulb? Well, we got 120 on this side and 0 on the other side, so the delta V would be 120. So here's what I want to do. Let's start by finding the resistance of the light bulb. Let's figure out, well, what would the resistance of the light bulb be? Let's solve for R, right? So the way we can do that is with the power equations. So one of the power equations, and I'll give you the equations on the test. One of the power equations is delta V squared over R. So if you rearrange that, R is going to be delta V squared over P. So the delta V is 120. The power is 75 watts. So the resistance of this light bulb comes out as 192 ohms. That's the resistance. So let's just put that in here. So we know that this light bulb is 192 ohms. Okay, now let's get to that. That's not the answer. P is power. P is power. Okay, so now let's get to the question. What they're saying is this. If there's extra resistance in this circuit, so when they say the conductors right here, each of the two conductors, look, each of the two conductors would be this wire and that wire. The wires hooking up the light bulb. So let's redraw the new diagram. So what they told us is that the wires used to hook up the light bulb have resistance. Very small, 0.8 ohm and 0.8 ohm. And then here's our light bulb, which we found out is 192 ohms. And then this is still 120 volts. Now guys, is the power of this light bulb still going to be 75 watts? No. And here's why. Because look, 120 volts, right? 120 volts and 0 volts. So how many volts do we got right there? 120. And then right here we got 0. Now look, when we cross this first resistor, we're going to be at something less than 120, right? Basically, my point is this. The delta V across this light bulb is no longer going to be 120 because this guy and this guy are sucking up some of the voltage. Does that make sense? So how do we figure out what the actual power of the light bulb is going to be? It's not going to be 75 anymore. How do we go about doing it? Well, hold on. That was kind of, well, what are you going to say?
I was going to say that in order to get that, you have to add all the 3 resistors.
Yeah, I like your thinking. That's what I'm going to do. But not because you told me to do it. Okay? You're not the boss of me. So look. These are all in series. These are all in series. Look, the current comes out of the battery, right? Current comes out. Current goes up like this. At no point does the circuit split. It's all series. So the way you simplify resistors in series is you add them together. So here we go. We got 120 volts. This would be 193.6. Now let's find the current. What is the current flowing in this circuit? And by the way, is the current in this circuit the same as the current in that circuit? Yeah, because they're the same thing, only this guy is more simplified than that guy. But the currents are the same, okay? Now, let's get this current using the simplified diagram. So using this simplified diagram right here, I equals delta V over R, okay? So how many volts are across this 193.6 from there to there? Okay, let's do it again. So 120 volts is 120 and 0. So how many volts right there? 120. How about right up here? 120. How about over here? 0. So how many volts are across the 193.6? 120. And then we got 193.6. So the current comes out as 0.62 amps. We're almost done. So this is 0.62 amps, which means what's the current over here? 0.62. What's the current right there? 0.62. What's the current right here? 0.62. So now we go to our light bulb and we're like, hello, I'm going to find the power. So how do we get the power? Well, if only we had a power equation that involved current and resistance. There is one. P equals I squared R, right? That's another power equation. I'll give them to you. So the current through this light bulb is what? 0.62. The resistance is 192. So this gives us a power of 73.8 watts. So basically, what happened here? Did I make a mistake? Where? No, because I'm using this now. I'm finding the power of this light bulb. Hey, look, if we would have used this 193.6, if we would have used the 193.6, then we would have found the power of the whole thing. All three, because like, look, who is this guy right here that I'm circling? He's all three, right? Do we want the power of all three? Or just the light bulb? Just the light bulb. So you got to focus in on the light bulb. That's why I use the resistance of the light bulb. Yo.
So after drawing the 192 ohm, how do you go from 192 to 0.8 ohm resistors?
Right here,
yes.
The 0.8s.
Yeah.
Oh, because that's what they tell us in the problem right here. It says so it's a long extension cord. Now look, inside an extension cord, I hope everybody knows this. An extension cord is actually 2 wires inside. In fact, I'll tell you a story after the video is done. I got a story for you. But look, if you open up an extension cord, if you get a little razor blade and cut it open, how many wires are you going to find in there? 2, actually 3, but one of them's the ground. But 2 that are carrying the current, right? So you got this wire, and what they're saying is, it says right here, each of the 2 conductors. The 2 conductors are the wire on the left and the wire on the right. The wires being used to connect the light bulb.
How did you know the watts was 120 and not 0? Oh, because it's going up.
The volts?
Yeah.
Because it says right here, at 120, and then here it says 120. All right, let's do one more.